All right, folks, it's 12:30 sharp. Again, this is Bill Murphy. Welcome to Geo 101. Uh, Thanks for being with us in this webinar series that we've been hosting here at ASP Enterprises, Quick Supply Company, and Bowman Construction Supply. I'm super excited to see that we have 87 attendees and the numbers increasing as we go. I'll do a little brief intro here. I am Bill Murphy, the engineer for all of our three companies you see down there in that lower left corner as the logo. And funny story, we have Don Tiemann on here as the host for this presentation. And I'm acting like I was running late to the office up here at Quick Supply in Iowa, that I needed him to set it up. But really, I just duped him into it because I didn't want to have to do it again. So hopefully Don's muted. You can't hear him laughing or saying
Very
yeah,
funny.
right. But
Very funny,
oh,
Bill.
there it is. So we've got a couple of first-time speakers on our panelists. They're not first-time speakers as given presentations, but this is their first webinar they've done live, and they're a little nervous. So what I didn't tell Don was I was going to purposely act like I messed up this morning, and I was struggling to make Mark Sternman and Ryan Anderson feel better about themselves, so they won't have to worry about messing up. They can't do worse than me. So you'll see out here on the screen it says use the Q&A feature. We've disabled the chat. We're using Q&A. Yeah, Aaron Carlson, I see you, buddy. Yeah, you're wondering if you can see it. We can see you. So anybody else, if you need to, if you know me personally, you can text me like that. And I think Aaron just want to make sure I gave him credit for attending. We've got 103 attendees, and the list is growing, and I'm happy to see some of our ASP Quick Supply and Bowman people on there. Once again, use the Q&A to send us questions during. We'll answer as many as we can live. But we're also going to answer all of those in writing later when we get back to you after you do your SurveyMonkey, when we send you the PDH certificate. I'm clicking in the screen and it says I'm controlling it, Don. There might be a lag. I may have already messed something up. Yeah, I don't know. There you go. So you guys could see the map on your screen. We're in 8 states, and we've always said the Midwest, but we picked up Bowman Construction Supply a few years ago, and we're so thrilled we did. A lot of folks in Colorado and in the Rockies tell me that they're not necessarily the Midwest, so we're pretty proud to say that we are across the Midwest and into the Rockies. And even from the great state of Colorado, we get some projects that expand beyond our borders a little bit. We have good relationships with people that do what we do, and that is construction supply materials in the civil construction industry and in the stormwater and environmental world. We have 8 offices. You can see them listed there, and we have actually over 50 years in business. I need to update my slide. A lot of our sales specialists are actually CPES, so they're erosion and sediment control experts. We do have one civil engineer on staff. That's me. I'm licensed in the state of Iowa. For our engineering friends on here, we never compete with you. We always help you. We're not in the engineering business. We're in the trusted advisory business on construction supply materials. I like to say that we are an important liaison between the designers and the owners and the contractors and the reviewers and the installers and maintainers, inspectors, everybody that's involved in a construction project. We get to be involved with all of those folks. We're all about relationships. We actually have over 9,000 customers. So we show some pictures here to give people an idea what we have, and I've skipped a couple of slides there. Some of our warehouses are very, very large. They're quite impressive. I'd love to have you visit your local ASP Quick Supply or Bowman warehouse once things get cleared up and we're free to go out and meet and greet like we used to. But for right now, we're all up and running. We have been fully operational through this entire COVID-19 quarantine, and we have our trucks running all over those states that we showed you earlier. We've been following a lot of safety protocols. In fact, we were one of the first companies that I witnessed following safety protocols immediately. And we have some of our staff at home while the rest of the staff are at the office, and we have our doors locked. We're not pressing the flesh, as they say in the politics business, but we are taking a lot of phone orders, and we're fulfilling a lot of orders. Our trucks have been very, very busy. Our warehouse has been very busy. With that, let me apologize if you hear some warehouse noise. I'm sitting in Quick Supply Company's warehouse in a private office, but you will hear some noise as we are open for business. And we are a very good logistics company. We can bring a whole lot of different site solutions to a site, make it convenient for the contractor. We're an important part of that relationship with contractors and owners. One of the neat things that's really grown over the last several years, and I've been with the company for over 5.5 years, is our relationships with all of those parties I mentioned earlier. We have some cities that count on us to help with innovation, especially in the stormwater world, in the low impact development and green infrastructure world. But one of the things we never want to do is lose sight of our roots and how we got started as a company. Geotextiles are at the heart of our operations, and they always have been and they always will be. Some of the products that we talk about may be considered commodities, as they are not as much the engineered products, but even commodities are part of a properly designed, properly installed, engineered solution. We take all of those solutions very seriously. So when we talk about innovative technologies on this mobile-friendly websites we talk about, we even have some of our suppliers for those rolled products that Mark and Ryan are going to talk to you about today. So please check out our websites, aspent.com, quicksupply.dm.com, bowmanconstructionsupply.com to learn more. But more importantly, reach out to us, contact us. There'll be some things that you asked today that won't get answered. And like everyone, you're going to think of some of your best questions once we're gone. Well, we're not really gone once the webinar is over. Reach out to us. Let us follow up with a lounge and learn. Since we're not doing lunch and learns in person now, we are doing lounge and learns, and that is we're providing you with the same knowledge and information that you used to get at lunch and learns from the comfort of your home or your private office. And we're able to do live Zoom meetings with you where instead of being muted like you are right now, all 122 of you and your coworkers, as many people as you want to do in your office, we can do those live. I think it's up to 50 when we do a live meeting. I wouldn't want to have more than 10 or 12 people on a mic anyway, but you can interact with us and ask questions. It'll be more than just getting talked to. You'll be part of the discussion with us. With that, I turn the slide to Geosynthetics. I'm going to hand it over to Mark Sterneman and Ryan Anderson, and I asked them to send me their boat bios, and I got both of them, and I just closed my phone because I told those guys to shut their phones off. But let me read it to you because this is fun. Mark Sterneman says, he's worked for ASP in the Fenton, Missouri office for 12 years. He serves the St. Louis area and Southeast Missouri. He's a member and enjoys participating in numerous industry organizations with engineers and contractors. Ready for this? He enjoys long walks on job sites, hiking up and down creeks looking at erosion. I'm uncomfortable. It says his kids do not like hearing about all the erosion he sees. Mark, I can tell you my kids are 23, 21, and 17, and they're still not impressed with what I do for a living. Ryan Anderson's on here as well, and it's hard to follow Mark's lead there, but Ryan says he's been with Bowman Construction Supply for 3 years. He serves the Colorado and the Rocky Mountain region. In his spare time, Ryan enjoys outdoor activities, and I can tell you, as a friend of his, he also enjoys working out, and he enjoys taking on projects of working on his own home and doing things that he's never done before, and he has taken the world by storm for us. So with that, I'm going to hand it over to, I believe, Ryan is going first. Is that right, Ryan?
Yes, that is. Thanks, Bill.
Yep, you're on the mic. Good luck, buddy, and I'm here if you need me.
Perfect. Appreciate
Don,
it.
you're going to hand the controls over to him? Got it.
All right. We skipped one forward, so we can go back one.
That's all right. You're going to have that happen sometimes.
Let's see here.
Everyone at home, give a nice golf clap to Ryan Anderson as he gets started.
Let's see if we can get back here. 1 second here. I'm not getting this to move. So here we go. So thanks everyone for attending. I think today one of our goals is to just give you a high level overview of geosynthetics and geotextiles. Geosynthetics come in a wide variety of shapes and different products. Today we're going to kind of focus more on geotextiles, geogrids. There's also composite geotextiles, geonets, geomembranes, geofoams, and geocells. I think one of the quotes I like about this is by integrating engineered products into your designs, you'll minimize your risk and maximize the value you bring your clients. As you guys are probably aware, some of these projects can incorporate many different geosynthetics into the project. A great example of that is in the bottom right corner. This was a project this summer actually from in Colorado, US 36 collapsed, and as part of that, we supplied geotextiles and geogrids for a wall-facing unit below this foam. Then foam was supplied. Then we supplied a geomembrane to protect the foam. And then we ended up supplying composite drains on top of that to help move the water and provide drainage. So, and then additionally in the front there, you can see geotextile bags. Big reds as ASP cells are dandy as Bowman has for erosion control. So geotextiles can be incorporated in projects in many different ways and aspects. Some of the applications for geotextiles would be some drainage or separation, roadway reinforcement, paved or unpaved. These are probably some of the most common ways that you guys will see geotextiles used. Roadway embankment construction, pavement optimization, pavement restoration, erosion control, or retaining walls. I think throughout this project, we hope that we can challenge you to look at geotextiles in different ways. Maybe think outside the box how you're going to use geotextiles and just kind of broaden your general knowledge of those. kind of the history of geotextiles. Geotextiles began in the 1920s with cotton fibers. And through that, you can see there wasn't a whole lot of innovation. Up until the 1950s, a spun bond non-woven geotextile was invented, and we'll cover that a little bit more. In the 70s, some of the woven geotextiles were performed, but recently, since the mid-2000s, there's been a lot of innovations. Tensar came out with the triaxial geotextile, Mirify came out with the RSI series, and the H2RI series. So we'll detail those a little bit later during this presentation. To start off, we got one of the most common geotextiles is a non-woven geotextile. That comes in primarily two different types. That's a needle punch and a spun bound. Needle punch is just like it sounds. Long needles that shoot at a very rapid speed go up into the fabric. If we were in your office, we could show you a sample of that. They call it, you'll hear people say Marafi or that felt fabric. That's a non-woven needle punch fabric. That's commonly used for drainage applications. Sometimes it gets confused for a landscape fabric, which a spun bound is typically used as a landscape fabric. If you can kind of see in that picture there, you'll see the fabrics spun through there, and that works as an excellent weed barrier, or for that application. You wouldn't typically want to use a needle punch non-woven for a weed barrier. The other type of common geotextile is a woven. Basically, you're going to see that in three types. Starting on your left-hand corner there, you got a slit film. In the middle, you have a woven monofilament, and on the far right-hand side, you'll have a high performance or a woven monofilament. More commonly referred to as your HP series, your RSI or H2RI. That bottom right-hand corner there, we kind of have a detail showing you a French drain that would be a non-woven. Mark, yeah, anything you want to add on that?
There's another slide coming up with the non-woven stuff in a bit. We'll talk more about them.
Okay. Geogrids. Geogrids come in all shapes and sizes. They've really evolved throughout the years. Probably your most common is your polypropylene, which is a punch and drawn geogrid. That's commonly used for your road-based stabilization. Your type 1 or type 2, or your triaxial grid, as you might hear people refer to. The other type of grid is a polyester geogrid. And that is an example of that is the second one over from the right. And that's a coated, those are fabric strings that are coated. Those are typically more used in a wall geogrid. You'll see in your MSE wall grids. Many times they're uniaxial. Sometimes they can be biaxial, and sometimes they can be used for road-based stabilization as well. But like we kind of talked about, geogrids can be used in all different types of applications. One of the common features that you use it, and probably the most common application for a geotextile, is drainage geotextiles. The most common fabrics that we sell or you'll see in the marketplace would be like a Mirify 140N, the N series, or the S series is the environmental series. But one of the things we will talk about too later is within drainage, you can also use a woven. You can use a monofilament geotextile that we'll cover a little bit later, but we just want to bring that to your attention that woven geotextiles can be used for in a drainage application if you select the right one. Some of the most common applications for the N series are French drains, or any type of separation where you're gonna have rock that's separated from the native soil and you're gonna drain it. They're also used for cushioning at times for liners or different types of construction applications. Anything else you think to add on that one, Mark?
Maybe like riprap is probably the place people see all driving down the road. You see DOTs installing fabric under riprap all the time. A lot of
that's another great example how you'll see those non-woven spec.
Let's see. Here's a slide that really shows the like Ryan said, the most popular application for a French drain. It's drawn in a way with fabric wrapping the whole trench, perforated pipe in the middle, or the example to the right, you don't even need the pipe. You can convey the water just through the rock alone. It's, in my opinion, humble opinion, really the better way to do it, wrapping the whole trench and not blocking the pipe. We sell a lot of what we call 4-inch perf with sock, where you put a geotextile actually on the pipe. And there's nothing wrong with doing it. It still works, but I feel like it diminishes the performance of the pipe by blocking the hole somewhat. If you size the rock appropriately, like a 1-inch clean rock, when you only have maybe at the largest a 3/8 diameter hole in your pipe, the 1-inch rock won't go to the 3/8 hole. You'll get a lot better flow through the rock, through the pipe, and convey that water away. And you'll use the non-woven fabric to separate the soil from the trench and the rock inside of it. It's I don't know. I'm sure everybody on the call has probably seen French drains and specified French drains before, but it's in our opinion, my opinion. Let's see, Brian, I think you still have control. If you can.
Yep. We'll go to the next slide here.
Here's a more real life example of this is basically a French drain. It's actually on an athletic field. This one is kind of neat because they use something. Oh, now I got control. I feel more important now. That picture with the French drain in the field, that was a lot of time spent establishing that subgrade. They actually have like a subgrade excavation plan on that job where they put the crown of the field in the middle, and that perforated pipe will take it away. Water will go into that trench. It'll ultimately be backfilled with clean rock and be conveyed through the clean rock and through the pipe itself. The subgrade excavation plan part of it is that it's higher in the middle. It'll ultimately be covered with synthetic turf, but maybe there's 4 inches of rock in the middle over that pipe, and as you get to the outside, there'll be up to 12 inches of rock or more. Here's another example, more of the riprap. This has a product that we actually sell called articulated concrete block mats. MoDOT uses a term. I'm from Missouri, so I use MoDOT a lot. But MoDOT has a term for riprap fabric. Like the industry says riprap fabric, but MoDOT calls it permanent erosion controlled geotextile. And I used to think, man, that's a long name for fabric. And then the more experience I got, the more accurate I thought that really is the most accurate way to call the fabric riprap fabric, because fabric is doing the work of holding the soil down. It's controlling the erosion by holding the soil where it's supposed to be. The riprap, or in this case, articulated concrete block, is doing its job of holding the fabric down and energy dissipation. But without the fabric below it, it would scour out around the rock, around the concrete blocks, and you wouldn't have ultimate success. And I didn't factor in the lag. I think we're going to move on back to Ryan talking about a.
So, yeah, and like Mark said, one of the key things that you'll see, even when you're doing riprap, is the separation, or any type of roadway. Separation is the separating and maintaining the integrity of two dissimilar materials. This can be really important to keep your aggregate clean, or for example, in the roadway application, keeping your aggregate clean. Your aggregate's expensive. It's tough to come by. So if you can provide a separation layer, you can keep that from going into the native soil, as you can kind of see below there, if you didn't have a separation fabric.
This is one of those examples of the old saying about 12 inches of rock and 12 inches of mud gives you 24 inches of mud.
You're very good at math too, Mark. So yeah, that's the old saying. So that is the key to separation anytime you're dealing with those type of applications. So yeah, that's a great example and great way of looking at it. The next portion, or the next key function of a geotextile, will be the filtration and the drainage application of it. Let's see if we can get this in. Trying to get this thing to move here. There we go. So like I was saying, the next key, one of the key, one way a geotextile can be used is separation. Another way is filtration and drainage. So filtration is, think about, is liquid moving through a geotextile. So that would be similar to it moving horizontally through a dewatering bag or any type of pass-through. Drainage is moving within the plane. That would be similar to like a pipe, a drain board, or one of the new fabrics that Mirify came out with would be the H2RI series, which can move liquid or provide drainage laterally within a plane. It's the only type of geotextile fabric that has that capabilities out in the marketplace.
So now we're going to kind of switch gears, and Don, I think if you give the controls back to me, I'll just keep them through the duration. And we go from non-woven fabric to woven fabric. So the non-woven fabric, like Ryan mentioned, is always the felt fabric, the Marathi, as people love to call it, and it's very popular. See it all the time. The woven fabric, people call and say, I need that shiny stuff, the slick stuff, the stuff that looks like silt fence. It's the woven fabrics that we get into. So there's the most popular one we sell, which is often the least expensive one we sell, is the X series of fabric, like 500X, 600X. I'm sure you guys have maybe specified them in the past or seen them be submitted in the past. They were kind of the original fabrics when it came to specifying them on jobs. They were really good at the time, and they have been replaced with a lot better things. They still have their place. We sell them on a lot of haul roads where, you know, the contractor has to go in and install a haul road with some big chunky rock, maybe to try and clean tires and stuff. And ultimately, after 3 months or 3 years of the job, they have to remove that rock, and it'll help with cleanup. So it acts as a separation and adds a little bit of strength. It doesn't bring a ton of value in strength. So if there's a poor subgrade, we probably need to move to something a little bit stronger. But we sell 500X, 600X all the time. The filter weave series is, like Ryan mentioned, is you're getting some of the best of the both worlds. You're getting strength from a woven fabric, but they weave it in a way that has a very consistent opening and has a high flow rate. So it lets a lot of water go back and forth. Part of the problem with getting best of the both worlds is the price isn't in the same price point as a non-woven and an inexpensive non-woven or an inexpensive woven, but it also has its place. We have a really good customer that does a lot of work for the Army Corps installing riprap in hard to reach places, like take their barge offshore and along rivers and other things. And they won't, typically when they're still putting riprap fabric, you didn't see me, I did air quotes, but they're still doing, using fabric underneath the riprap, but they might use the filter weave fabric because it's a critical application that basically no one ever wants to go back to again. It costs a lot of money to move a barge and get it there. So sometimes we'll sew the fabric together and make giant panels of this, but ultimately they just want to, they'd rather spend a little bit more money on a high quality fabric so that they don't have to come back to that in the future. And then you get into HP fabrics where they have more material in them, stronger, higher grab tensile strength and other properties. They address the flow rates more, so the flow rate in HP product will be a lot better than the flow rate in an X series product. And the high strength series of geotextiles are, they're extremely high strength. A lot of times they're made out of polyester rather than polypropylene, so they have they can reach their ultimate tensile strength a lot faster. These are in some really critical applications. We sold a really neat job on a bridge abutment that a lot of you guys might know Guy Lidikin. He travels all around our territory. One of his favorite jobs that he sold was a bridge abutment basically over a swamp, and multiple layers of this high strength fabric that couldn't move in a very critical application with a road above it. Probably just pounded that arrow key a little too hard and you guys could all hear it, but and hopefully it will actually advance too. Or it won't. One or the other. Someday it might get to the next slide with these geotextile applications that are, there you go. Subgrade. So for the woven fabrics, we're trying to improve the subgrade or optimize the pavement. Improving the subgrade is, you're improving the performance of the rock. You have poor soils below it. You install a geotextile, whether it's a fabric or a grid, and you improve the performance of the rock above it, trying to eliminate rutting, eliminate a dump truck getting stuck. Alternatively, pavement optimization would be, maybe you have this so-so subgrade below. Maybe by using a geotextile of some sort, we could reduce the rock section, reduce the pavement section. Asphalt is not very hard to reduce the asphalt section. Concrete, being a rigid pavement, is harder, but Ryan has done it in the past and made it. And the better option in those pavement optimization is maybe leaving your cross section the same and improving the life expectancy. So it's something you don't have to come back to and work on again down the road. Let me see. I think Ryan's going to talk about the next slide, which is some pictures of every option. I wish I could get it to go better. There you go, Ryan.
Perfect. Thanks, Mark. So I'm sure a lot of you guys have been out to a job site and seen something similar to this. What we kind of want to detail here and show you guys is how the different fabrics look when you got to a job site from a separation standpoint. If you look on your far left-hand side, that would be a non-woven geotextile. Similar to your 140, 180, 160, 180N. The middle is a geogrid. And on the right-hand side is an RSI series, or a high-performance woven geotextile. As you can see, is if you went to go push aggregate over the top of it, on your far left-hand side there in the non-woven, you can see the water bleeding up through, and it's going to sink. It doesn't have a lot of tensile strength compared to the RSI series on the far right, which has tensile strength and will provide you the separation. In the middle, you can see the geogrid, and what would happen as you went to push your aggregate over there, it's going to snowshoe effect, but you're also going to get mud, as you can see, pushing up through those, which is going to cause contamination of your aggregate level. So we just kind of want to show you guys what that would look like with these different types of geotextiles out on our real world job site. I'll go to the next one, Mark. And within that, we'll kind of talk about flow rates. So you guys can all read these pictures, but I pulled a couple of the data sheets up just to give you comparisons of that. 140N, kind of like what we talked about before for the French drains, the non-woven fabric, that flows at 135 gallons per minute compared to a 600X that flows at 4 gallons per minute. So you can see the different flow rates. If you look at the RSI series, the 380i, that flows at around 85 gallons per minute. So that is a step up from the HP series. It will provide you the strength, but will also provide you a significant flow rate, which the HP series does not. And like we talked about beforehand with the Filter Weave series, which is a woven geotextile, but also can provide great flow rates. But even within a very similar name geotextile, you can get dramatically different flow rates. So for example, a Filter Weave 402, which is an ash tow geotextile, will flow at 145 gallons per minute, where a Filter Weave 404 will flow at 70 gallons per minute. So not all geotextiles are created equally, and we just want you to think about that when you're specifying geotextiles and looking at geotextiles for your job site.
So how these bring value to your pavement sections. As you see, that tire would roll down and it will put force on the pavement below it and on the rock. That rock will want to move down and out and then back up. And that's what ultimately creates that rut that no one wants. The goal of the fabric is it works by friction, because again, if we were able to be in person and we had samples with you, you could tell. But like that, I mentioned the 500X being shiny and slick and everything. Not a lot of friction on that geotextile. On the high strength fabric, one of the things that they improve it on is how they weave it, and it has a lot more friction. So the fabric that's 5 feet away from where that tire is has friction between the rock and the subgrade, and it doesn't want to pull over, and it has that tension to keep the the rock from moving. Geogrid works in a little bit different way, where it works with interlock, so the rock will strike through the grid and lock up the rock above it, and it'll keep the confinement so that the rock doesn't move under the pressure of the tire and hopefully not create the rut. The reinforcement part is it adds the tensile strength that, you know, it's got to be strong enough when a force is pulled on it that it won't tear and rip. And it improves the tensile strength just like rebar would in concrete, and improves the bearing capacity of that rock section. That's how we improve the rock section, by improving the bearing capacity of it. In this picture, you can kind of see on the left how those arrows go down. The wheels put a force, rock moves down and out, which is not good. The picture on the right with the rock striking through the geogrid, if it was geotextile, it would be having the friction and the rock would be supported, and it would push out and spread that load out.
Hey, Mark, the key there too is it shows how the separation works.
Mm-hmm.
So on the left-hand side, you can see without a separation layer, your aggregate's just going to push into your mud. And on the right-hand side, your geogrid is providing the separation layer through dissimilar size of materials. So just another aspect of that portion.
It's the same kind of idea in this slide, where the grid is locking that section up, being porous down, creating snowshoe effect, spreading out the load. Even though this looks like a rut, it's the idea of the geotextile being in tension. And a lot of times somebody might tell you that a geotextile has to be strained and reach that ultimate tensile strength for it to perform the best way that it can. And it typically achieves those strains during construction, with construction traffic running over it. A lot of times on job sites, the heaviest loads that anything's going to see is during construction. Dump trucks backing over things, you know, trash trucks taking dumpsters away. It achieves these things just going through the construction process. There's another slide, I'll just wait for the lag, but it's coming up, where it shows, you know, how the lockup, the interaction of rock and geogrid work. Like those billiard balls in the triangle, they wouldn't stay like that without the triangle. The size of the rock matters a lot with geogrid. If you use too big a rock and it won't strike through, then you're dramatically reducing the effect of the geogrid. Rock will move around on top of it, and you're only getting really part of the value. So you need to use the appropriate size rock when you're using geogrid. With geotextiles, it doesn't matter as much. Geotextiles work off of friction, so if you have giant rock on top of it, it doesn't really matter. You want to eliminate void space because it doesn't weigh anything, but the size of the rock is not as important. And that picture in the right is just there to show you what the snowshoe effect is, how that pressure of that wheel is spread out in all these directions and will give you a greater bearing load. So we have a couple examples of where we would place geogrid and how it would work. This is a very normal design. You know, you start with hopefully you start with perfect subgrade and you have no worries and it's the best job you've ever been on, but that doesn't always happen. So you start with unsuitable soil, poor subgrade, low bearing capacity. Your normal design would be to cut out so many inches of rock and replace it with select fill, like a minus rock or something. And maybe after you do that, you end up with some type of rutting, long-term settlement, and the wheel loads coming and showing. How many times do I gotta click it? There you go. Then you get the wheel. So this one shows a little bit more like that subgrade started with a CBR of 2, which is not terrible, but it's not perfect. It could definitely be worse, but it could definitely be a lot better. So you get that rock moving out to the sides, rutting. And the way we would address it would be to add a layer of geotextile, grid, fabric, whichever. In a perfect world, we could do it with, you don't have to cut as much soil so that there's less haul off and you can fill with less rock. There's 24 inches of rock in the middle section, 12 inches of rock on the section to the right with a layer of geotextile. So there's 12 inches less of haul off and 12 inches less rock to haul in. And you end up with the same design life or possibly a better life expectancy. Alternatively, you could still keep the 24 inches of rock and put that geotextile all the way to the bottom of the 24, and you would just dramatically improve the life expectancy of that pavement.
Hey, Mark, a couple other key, I think, takeaways on that portion too, is when you're thinking about that is, like Mark was saying, if you can reduce your cut or the over X portion, you can dramatically reduce that construction time. So if you're working on a city or municipality project, you can get those city roads open quicker and faster, which the local people like. Another big aspect of that is if you're hauling 24 inches of rock and you're doing a major thoroughfare for the municipality, a lot of those side auxiliary roads are getting a lot of wear and tear that they weren't designed for, from all the trucks coming in there hauling rock and moving that type of material. So you can reduce that impact on some of those side roads. I'm sure some people out here have done major city projects, and then the side roads end up getting so beat up from all the construction traffic on the auxiliary roads. And one other thing, I think another thing to mention about using a geosynthetic in that type of application compared to, let's say, like a lime or cement treatment, is you reduce the curing time. So if you're going to do a lime or cement treatment on there, you can if you use a geotextile, you don't have any curing time, and you don't have to worry about weather constraints. You can just push your aggregate right over there. You don't have to worry about the freeze or thaw or rain. So there can be a lot of benefits of that. And just to jump in this slide, we covered a lot of different geotextiles, from the non-woven, from the monofilament, slip film woven, the geogrids, the high performance, and the RSI. And kind of like what we've hit on throughout this presentation is different geotextiles have different characteristics and different strengths and weaknesses. So this just kind of gives you an overview of which type of geotextiles are good for which type of applications. And like Mark was saying with the geogrids, kind of since basically 2010 when Mirify released, I believe, the RSI series, the high strength geotextiles kind of combine both the geogrid and the geotextiles into one product, so it can eliminate that double of insulation. You get the separation and you get high strength, high tensile strength and stability. Also, one of the other keys that we've hit on throughout this presentation is with aggregate size. If you see in the bottom left-hand corner, you can have a large pit run. If you use a geogrid with that, it wouldn't work. That large rock wouldn't strike through the geogrid and wouldn't create interlock. It would almost slip plane across the top of it or just destroy the geogrid. With this fabric, you can push that, or you can push that rock across there. Maybe that's on-site fill, so you don't even have to import any material, and you can move forward with your project.
We put that picture on here because that was a project that Don Tiemann came up with the solution on when he was in the office and got called. And Don is Ryan and I's boss, so figure it can't hurt.
Nicely done.
Yeah. So we wanted to touch on a few things. We get a lot of these questions about installation. You know, what somebody wants staples with their order of geotextile or geogrid, or how much is the overlap? And like overlap, we don't have a good answer because overlap is very dependent on what the subgrade is like. The manufacturers always recommend 12 inches to start with. So can you get away with 6? Probably. If the subgrade is really good, you can do 6 inches. Ultimately, you want 100% coverage. And if you're on a really poor subgrade where you install it and you overlap at 6 inches and a dump truck drives over it and you create a 1-foot rut, you're going to pull material away from the overlap and you won't have 100% coverage. So overlap's very much dictated off the strength of the subgrade, but it always starts at 12 inches and mostly goes up. It can even get to the point on some jobs, like if we're trying to use a geotextile to do a ash pond closure, in those cases we'll sew the geotextile, so you won't even have an overlap. It'll be a sewn joint or sewn seam. No special pins or zip ties or anything like that. You can use staples if they facilitate it. If it's a windy day, you can use a pile of rock. On Geogrid, it's really best to just start pushing rock on it and let any kind of wave work its way out. You can definitely get on top of the equipment. You just want, or on top of the geotextile with equipment, you just want the rock down first. Tailgate dumping is a great way to install aggregate over geotextiles and geogrids. And the other one that a lot of people want to do, contractors always want to just get on top of something with a roller and turn the vibrator on and try and get everything to lock up as quick as they can. And it's not always for the best, because when you use the vibratory compaction, it might bring moisture to the surface that you don't actually want. So typically we recommend just rolling right over it with the sheep's foot or the roller to compact your rock. And a lot of times it will lock up and improve instantly. And you don't need to use the vibratory compaction.
I love that. That's the kind of advice that you guys provide that makes you experts, more than just somebody buying a product off the shelf and going home and saying good luck with it. There's a whole bunch of different things that you guys provide for tips and tricks that the earlier and the more often you get involved, the better off the user will be. Good job.
There's also something too, and we didn't really have this in here anywhere, but it's worth throwing in. Sometimes jobs come out. I just bid a MoDOT job yesterday that required manufacturer's rep on-site assistance for 3 days. It was in a vegetated reinforced slope with Geogrid. We love seeing stuff like that. You can tell from my bio that I enjoy job sites. It's, you know, I'd much rather be on a job site talking to somebody than sitting in my office looking at my computer. So if you ever feel like I would really like to put something in my spec that requires a manufacturer's rep on site, do it. It can only lead to better success. And if there's somebody, a manufacturer that doesn't want to go to a job site, then there's something wrong with them. So
exactly. It goes right along with what you talk about with the pre-con meetings. Pre-con meetings are very important, but a lot of times during the construction, the same person that was at the pre-con might not be on the site. So if you're there, you get to help them. Good job.
Yeah. And we're really invested in the success of the project and the success of the engineer that specified the job and the contractor that won the bid, all the way to the owner. Like we have this saying that I use it more for turf reinforcement mats and erosion control, but a bad TRM job is bad for all TRM, not just the one specific one. And that applies to geotextiles too. It's, you know, whether we sold grid or someone else sold grid, we don't want it to go poorly because we don't want people to be averse to using it. So kind of getting back into something, wrapping some stuff up. You may have seen this chart in the past. It's something we used for tons of years. And to be honest, it's just not very good. It was the best available for a long time, but it's very subjective to the person that's using it. So it's, you know, I get a lot of phone calls like, oh crap, we hit bad soil. What do we do? How bad is the soil? Will a loaded dump truck rut 1 to 3 inches? And it's subjective of the guy, you know, if he wants to get out a tape measure or not. So it's something we used when it was the best available, but now we have something that is a little bit better available, that guy. But he's holding a DCP, which you guys probably know 10 times more than we know about. But it's a tool we invested in to try and make us have a more qualified answer for contractors. It's not something that we ever want to take business away from an engineer. It's always recommend hire a geotech, have them come out and do what they're great at doing. But if we can somehow help by having a more educated opinion about something and have better conversations, maybe eliminate 2 or 3 conversations to get more productive conversations going. And it's just fun being on a job site, figuring something out, satisfying curiosity. I could tell you that the CBR of that soil outside of our building in Fenton was above 4. So basically, once a CBR is above 4, we're not looking very much to use a high-strength geotextile. Another tool that we have that we can use is Mirify and Tensar. Both have design software. Mirify and Tensar are 2 main geotextile suppliers. They're leaders in what they do, and they've invested a lot of money. They spend more money on research than everybody else. They spend more money on testing than everybody else. They both have developed design software that is tremendously valuable. This is a snapshot or screenshot of Mirify's design software. Without going through the whole thing, it basically tells you all the inputs that you put in. 20 inches of rock is equivalent to 6 inches of rock and a layer of RS580i. I bet it took less than 3 minutes to come up with this design. once you knew the CBR. That's the factor that changes everything. A CBR of 5 wouldn't even need the RS fabric probably. CBR of 1 would change everything a lot. So it's CBR is important. Everything else can be an assumed value that we can correlate to other designs. Tensar has their design software. We took a screenshot of theirs to show like what you might be able to do for pavement optimization. And this is the kind of results you get where without Geogrids, you get 9 inches of base with 3.5 inches of asphalt. With a layer of TX5, you could go to 6 inches of asphalt or 6 inches of base, 3.5 inches of asphalt. And by the way, it also increases your easels by double. So you use less rock, less dig out and haul off, less rock to haul in, and you dramatically improve the pavement life expectancy. In the other example, it's maybe a little bit less value that it brings. Only save 2 inches of rock and 1 inch of asphalt, but more than pays for the Geogrid.
Mark, so that's an excellent transition. I didn't mean to talk over you, but just for the sake of time, we've got about 9 minutes left of going through slides. So if we want to get to the Q&A, we can go quickly through the next few things at the end. It's up to you.
I want to get to Q&A, and these are just a couple of pictures of some other things, some things that might fall into geotextiles that we sell. Load support. GeoWeb is something that falls into that category, and we can do. It's a neat tool that does a lot of things. It shows kind of how important confinement is. So it's actually got 4, 6, 8 inches of vertical confinement. It was invented by the Army Corps to build runways in the desert. So we put it in there because it shows how important that confinement is, how it can spread out that load. And I'll be honest, it's expensive. It's way more expensive than a layer of geotextile fabric, but it might be what you need in certain applications. Building where you're 3 hours away from a quarry. We're blessed in Missouri to have inexpensive, good quality rock around every corner. But if you travel 2 hours south of St. Louis, quarries are not as prevalent. So it's a solution that can change things. Liners are something that we do. Ryan, I don't know if you had a quick thing you wanted to add about liners.
Not a ton. I would just say a couple of big things about liners for people who either specify them or working with them. Think about seaming. Whether you can use a solvent or a tape with a PVC or EPDM, you can use a solvent or a tape. Whereas a lot of the other liners listed, you'll need a heat weld gun, or potentially if you don't have that, a technician to come out on site. Just a couple other things to think about is UV stability. PVC is not UV stable, so if you're going to try to use it on a project that's going to be exposed to the sun for many years, it's going to fail over time. And I think another big thing is hydrocarbon resistant. Are you going to have a potential for any hydrocarbons, diesel or gasoline to be spilled on that? If so, think about your liner selection. We just wanted to kind of spark that idea and that thought process whenever you're looking at liners.
Mm-hmm. And one of the things we're really good at liners and a lot of other things is knowing who to call. If you call your local ASP Quick Supply Bowman guy, salesperson, we might not be the world's greatest expert at a liner, but we know them and we know who they are and we can connect people. This last one is just something neat. Ryan and I both really enjoy talking about, but it's a high strength geotextile that they sew into a really specific shape, pump full of the wettest concrete you've ever seen. And it's a tremendously good erosion control product that is inexpensive. I happen to think it looks really cool, but I know that's subjective. And so it's just something different you can do with geotextiles. That really kind of wraps up everything that we had. I see that there's some questions, Bill.
Yeah,
I don't know.
I can help you with those. So, man, I told you 9 minutes left. You chopped it right down to about a minute and a half. That was quick. You guys did a great job of keeping us on track, and I appreciate it. One of the comments was not really a question, but Bill Heatherman just said he likes your point about wrapping on the outside of the rock instead of just against the pipe because it makes sense. That's just, again, one of those tips that all of our sales staff are technical people, and you guys just have so much world experience. I say you guys, for those who are sitting here on this webinar, I'm not a salesperson. I tell everybody that, and those of you who know me know I say it all the time. And it's not because I don't want to be considered one. It's because they deserve better respect than that, even because our sales team has so much vast experience, not only on the proper design and selection of the materials, but just on getting it on site, handling it, properly installing it, maintaining it, pros and cons to different options. Because a lot of things we run into are not just one answer fits everything. We can give you different options and different budget costs for those things. But him thanking you for that tip is pretty cool as far as I'm concerned. And one of the questions that was asked, and one of you guys mentioned it, was, and we're going to get a little specific. We won't have time. It's 1:20 now. We're going to wrap this up right at 1:30. We'll get into some of these, but why is non-woven not necessarily good for landscaping versus woven? And I think that could have been a little bit of a misunderstanding, because it depends on what they mean by landscaping. So for just someone considering landscaping, would one of you touch a little bit on non-woven versus woven?
Yeah, I think it's probably why was needle punch non-woven not as good as spunbound non-woven.
There you go.
And so needle punch non-woven it's not the end of the world. It's better than nothing. And I think it probably would even be more specific to weed barrier. So weed barrier, people asking me for weed barrier is really one of my least favorite questions, because weeds grow from the top more than they grow from the bottom. And birds drop seeds, wind blows seeds, and weeds grow. They're invasive. They get that name for a reason. So, someone asks, is this weed barrier guaranteed? And my first answer is no, not at all, because weeds will grow from the top. But it's easier for a weed to grow up through a needle punch non-woven than it would be for a spunbound non-woven. Spunbounds are typically, they call it colandered, so they're heat treated on both sides, and it just makes it harder for weeds to grow through them. I don't know if Ryan, if you have something different to add.
No, I think you're spot on. I think the other thing too is typically they use a really thin one, so they'll use the 140N. If you have a fabric sample, or if you want a fabric sample, fill out the survey and we can drop you off one. But if you hold it up to the light, you'll actually be able to see light penetrations through there, and you almost see the fabric clump in different areas. So that can allow the weeds to grow through in those areas as well.
So there's another question about, does riprap slide if it's placed on a geotextile? I don't think it really ever slides. It definitely falls, but I think it falls, it's gravity more than it is the geotextile, and it's based off of the slope. So it's not an issue, I would say.
Well, if it is a steeper slope, that's where and I made you skip past it. That's where we talk about something like a GeoWeb to get that cellular confinement to hold that material in place.
It's more about the steepness of the slope than it is the geotextile. Filter weave fabric is woven, but it has a high flow rate similar to non-wovens. So it's made on a loom, like woven fabric is.
And I get some emails or some questions via email and text as well. So one of the email questions was, how do I know when to use a heavier weight non-woven? And that tied in with somebody who said, is there an easy way that I can have cliff notes or like a cheat sheet to tell me which product I should use in certain situations, so I don't have to do a lot of research, since this isn't something they do every day?
Yeah, so again, to plug our boss, because that's what people do. Years ago, Don Tiemann took the time to make what we call fabric selection guides, and we have one for every market we serve. I share it a lot with people, and it's a really, it's more valuable than a cheat sheet. So I don't like calling it a cheat sheet, but that's a really cool tool, and I would recommend anyone reaching out to their local representative asking for it. And if you want to put on your Survey Monkey, the one that you need one, I think we can send it back to them.
Yeah, if that's not too big of a PDF, I'll talk to Don offline about that.
Bill,
I'm glad Mark mentioned survey. Go ahead.
Yeah, well, the one thing you said was, how do you decide which fabric to use, like specifically with riprap? The heavier weight non-wovens are for the heavier rock. So like whether it's a municipality or a MoDOT, based on the rock size, they'll go heavier on the non-woven. So it's pretty much practicality too, that as you get bigger rock, you want a stronger fabric for constructability.
Don Tiemann, ladies and gentlemen, that was awesome. I'm glad you unmuted yourself.
Hey, Bill, too, I think to Don's point, we did a project last year where they were dumping huge boulders on there. We ended up bringing in 32-ounce fabric, like Don was saying, because that's what they're using it as a cushioning, and it was so that it wouldn't tear a liner beneath there. So just like Don was saying, I mean, you can get fabrics up to 32 ounces. So there's, just to add on to Don's point there.
I love it. Good job. Mark and Ryan, you both are getting points with Don. I think that's fantastic. And Ryan's bragging about the big rocks in Colorado, folks, if you didn't pick that up. But we have big rocks in the Midwest as well, but we don't necessarily have quite as steep a slopes as they do in most areas. Now, we do have some bluffs, and we do have a lot of different terrain. So for those of you that are still concerned, Mark, what do you suggest? If they still need some more technical advice, what other resources are available to them?
Yeah, so I think the first place to get, if you have technical questions, is lean on, we're lucky. Our owners of ASP, Bowman, and Quick Supply really invest in our sales force. They give us opportunities to do a ton of training, and they give us vehicles to travel most of the time. And to lean on the sales reps first. And if you need help getting in touch, who your local one is, our website's a really good place to see that. Or just call an office and ask, because we got really qualified inside salespeople too. And the sales rep can really help you connect with the specific manufacturer that you're reaching out to. If you have a geotextile question, we can lean on Mirify and Tensar. If you have a liner question, maybe we lean on different liner manufacturers. Like I mentioned, we're really good at connecting people. None of us, I think, are too proud and try to act like we know more than we do. And I guess that's my answer.
Thank you, Mark. And I'm going to go ahead and start bringing this home for us, fellas. There's always going to be a few questions left. One of the great things that we do is we answer all these questions in writing at the end of every webinar. So folks on this webinar, what you can do as participants is answer the Survey Monkey. Don's going to send out the link to all of that at the end. It'll just have your name, your email address, and your city. We already have that data, but it's good for us to put that all in one location from this webinar so that we can do follow-ups. We'll assign those follow-ups to each individual branch, and then we'll answer all the questions in writing. One other thing we'll talk about is that fabric selection guide. If we don't send it as a PDF, we'll just tell you where to find that on our website. That's a great tool to have available to all of you. And again, Don is the host for this, and I am Bill Murphy, and we're both we're really co-hosting all of these webinars throughout the series. Thanks for joining us. We got a couple more coming up. And I think, Don, you're running it. If you go to that last slide, they'll get their PDH certificate when they send us that Survey Monkey. And we'll also have two other things on there. One is, do you have specific projects that you need help with? And the other is, what's some feedback for us on this webinar and others? We are taking next Wednesday, May 20th off so that I can replace my computer and I can be better at being on time. But we're also going to have vegetative wall system, and these folks come out of Canada, but they've got a lot of projects in the U.S. and across the world. Pretty exciting solution we have there, and then we're going to have another one for soft armor solutions after that on June 10th. Look for news from us to plug in some more. We've had a lot of success with this webinar series. We thank you for your time. We know your time is valuable. I really hope you're all going to start transitioning back to work safely. I hope you and your families are staying safe. And from us, we say thanks for staying with us. We've really done a good job, as the news says, on pivoting, and we refocused our efforts. We're grateful to be able to do a lot of this online, but we miss seeing you. Let's do both. Let's just keep doing both. We'll keep doing these virtual meetings. Let us help you and your company. If you've thought of some things that your coworkers or people you do work with could benefit from, reach out to us, and we'll do this directly with you with all the live mics so we can have an interactive conversation. But we also will continue to do the web series as well, just present to you. Again, be safe, be hope-filled. Anything you guys want to add there at the end?
Be honest on the Survey Monkey. If we need to improve on something, let us know. Or if there's a topic that you would like to hear more about, maybe you want to go from this one into learning about high-strength fabric. Just don't worry about our feelings. Just be honest.
That's excellent. It helps us continue to be your most trusted site solutions specialist. We take that very seriously. With that, we're good. Don, Ryan, thanks again. Mark, good job, guys.
Thank you all.
Thanks, everybody.
For listening.